All right, I think we're ready to go.
Awesome. Welcome to the first installment of Snowmass Early Career Frontier Introduction Series, brought to you by SEC Inreach. SEC Inreach is currently headed by Cindy Lynn and Christian Herwig. I want to thank also our Zoom host for today, Joshua Barrow. And I would like to introduce our first speaker, Jacob Zettelmeyer, who is a postdoc at Fermi National Accelerator Lab and received his PhD from Indiana University in Bloomington. Dr. Jacob Zettelmeyer for the Instrumentation Frontier.
Hi, so yeah, thanks to Tiffany and the Inreach group for organizing this and giving us the opportunity to introduce our frontiers and then specifically the Snowmass Early Career Frontier efforts. Okay, I thought that was working. So I'm going to present specifically a quick introduction to the Instrumentation Frontier, starting with the overall efforts in Snowmass and then moving on to the early career efforts specifically. So the Instrumentation Frontier is led by the three conveners, Phil Barbeau at Duke University, Petra Merkel at Fermilab, and Jinlong Zhang from Argonne National Laboratory. There's a lot of information on the Snowmass Wiki, which is located at this site on the instrumentation. I've got a lot of links. I only have a short amount of time, but there's a lot more information on the wiki, and at a few meetings, I'll point everyone to. There's a Slack channel, overall instrumentation on the Snowmass 2021 Slack page. So specifically, the Instrumentation Frontier is meant to discuss advances in detector technology and R&D needs for future experiments across physics. So it spans collider physics, neutrino physics, intensity physics, cosmic frontier. Basically, instrumentation kind of wraps everything together. So it's important to say what is the future of instrumentation, and say things like detector R&D. And there's a lot more information. There was a kickoff meeting for the Instrumentation Frontier to kind of introduce everything back in mid-June. The Indico link is here, and there's a lot more information there than I have time to provide on these slides. So there's 9 Instrumentation Frontier topical groups. These are quantum sensors, photon detectors, solid state detectors and tracking, trigger and DAC, micropattern gas detectors, calorimetry, electronics and ASICs, noble elements, and a cross-cutting group. There's 3 to 4 conveners for each topical group, and each group has its own mailing list and Slack channel on the Snowmass 2021 Slack. And then there's again, point you to that wiki page for more details on how to join. My slides are already posted on the Indico page for this meeting, and these links should connect you to these pages. So quickly going into kind of the upcoming deadline of the letters of interest. These are short, very brief 2 pages kind of summarizing an idea that you want the conveners to consider. And these letters of interest will kind of feed into the planning for a meeting that'll take place in early October virtually. And these are, anyone can upload these. You don't have to be affiliated with our early career efforts. Anyone can upload an LOI. It would represent existing work or a new idea that you have, will help the conveners plan the work of the frontier. So if you submit an LOI, it's much more likely that your idea will be considered in the planning of meetings. People will know about it. It could help you, provide a collaboration if others are interested in your ideas. And if further developed, could lead to a contributed paper, which are the main efforts of the Snowmass exercise, and those aren't due until July of 2021. So I don't go into much detail about that here. But more information is available in the kickoff meeting about that. So now moving into the early career efforts. We're essentially a liaison group advancing the interests of the early career members in the Snowmass process. And we've defined early career loosely as students, postdocs, early career technical and scientific staff, and non-tenured faculty, with the caveat that if you feel this label of early career applies to you, then you are certainly welcome. We have an initial organization structure in place, and as I'll mention multiple times, there are plenty of opportunities to get involved, and we're actively looking for more people to get involved. So please get involved. we advance initiatives of the early career community, specifically relevant to instrumentation, but broadly as well. Encourage early career members in the Snowmass process, essentially integrate our members into the different Instrumentation Frontier topical groups. I'll go into that a little bit more. And we share the early career member input at convener or topical group meetings. So we've current organization of the group is we have 3 current leaders of the group and initial liaisons to all 9 Instrumentation Frontier topical groups. As I'll show, there's plenty of room and ability for anyone interested to get involved. So again, if you're interested, please get involved. We're developing initiatives that are relevant for people working, studying with instrumentation that may become letters of interest or recommendations that are brought up in meetings. Our recent meeting of the early career group on July 29th has a brief outline of our current initiatives. And as I'll have at the end, we're having a larger meeting to encourage input from all early career members. We welcome input from anyone interested at the meetings that we hold, which are occasionally to discuss our initiatives and report from the topical group meetings. And we have a Slack channel at Early Career Instrumentation and an email list, which is listed below. And I've included instructions on how to join that on the slide, or you can contact me to be added, or if you have any issues with this, procedure here, and I can add you directly as well if you're interested. So I guess broadly, why should you join us? Why is instrumentation important? So instrumentation advances would be an integral part of advancing experiments to next level of precision through detector R&D or unlocking even greater array of possible physics measurements. And this group will help plan the near and in our case, this early career, possibly even farther future of instrumentation across high energy physics. And there's a broad overlap with all frontiers. So detector R&D and instrumentation advances are used in essentially has overlap with almost every single other frontier in Snowmass. So the current leadership group, again, this was decided basically by volunteer. At this point, if there's room for more people to show interest, and if you have interest in being a leader, I'll kind of define what that is in a second. So is Stephen Butalo, who's a graduate student at Florida Institute of Technology, Catherine Dunn, who's a graduate student at Stockholm University, and myself, Jacob Zettelmoyer. And then I won't go through this table, but we have a current list of topical group liaisons. And again, we're looking for more liaisons. As you can see in this table, there's a lot of repeating names. This was kind of done out of necessity. We wanted to set up something where we had representation in all the topical groups. But we're certainly looking for more liaisons. And if you're interested, I've included a link to where you could sign up to be a part of this. And to tell you a little bit more about what that would mean, the position responsibilities. So the leadership is essentially more coordinating meetings, so emails, Zoom info, advertising, that kind of thing. Attend the Instrumentation Frontier topical group and conveners meetings as liaisons to the early career group, and give updates to the convener group of the Instrumentation Frontier and the larger Snowmass early career group. So as I said, the initial leaders are volunteers, but if there's more interest from others, we can rotate positions, create leadership shifts. That would be something to be discussed if there's broad interest from others. So the topical group liaisons essentially attend and give updates from those topical group meetings and workshops. Those are ongoing. There's a calendar, I believe, on the Snowmass wiki that shows those meetings. They bring up comments in the topical group meetings for any member who can attend or doesn't feel comfortable speaking at these meetings. Amplify the initiatives in the topical group meetings for the early career Instrumentation Frontier and the Snowmass early career group. So if you're already attending a topical group meeting in instrumentation, and you're interested in becoming a liaison to that group, the current liaisons, we've got a Google Doc that essentially lists that table that I mentioned. Please, if you're interested, add your name and contact us, or add your contact information if you're interested in either a leadership or a liaison position. We welcome more liaisons to the topical groups for as broad a representation as we get, and to make sure that no one person in the group will have too much on their plate at one time. If you want to contact us further, you can contact a liaison on Slack, through email, or we have a Google form where you can essentially send anonymous comments or interests if you want to communicate with the group. Again, we welcome further participation and more input into our initiatives. Some important points I want to make. You do not need to be a leader or a liaison to attend our meetings. You do not need to be a leader or a liaison to volunteer with or bring up your own initiatives at our meetings. We're certainly interested in more volunteers, so you can volunteer to be a liaison at any time if you're interested, and you can stop being a liaison at any time if you get too busy, you have a lot of other things to do. So you certainly don't want to make people feel obligated to basically participate in these roles ad infinitum. We want to make sure that there's a way. So the last thing I want to point out is we invite the community to a workshop to discuss further initiatives. This is specifically for the Instrumentation Frontier and LOI submissions. This will be held today at 1:30 p.m. Eastern, which is about 30 minutes after this meeting. So if you're interested, please attend that. I believe it's been advertised. I forgot to include the Zoom link on my slides. Main idea would be to organize the effort on our initiatives, direct effort to many already existing conversations within Snowmass, and identify community engagement frontier topical groups relevant for discussion, LOI submission, overlap with ongoing efforts in this area. Please join us, and I'll re-upload my slides, adding the Zoom link to this meeting. So please join us if you're interested, and that's all I have, so I'll be happy to take any questions.
Awesome. Thank you, Jacob. If you have any questions, use the raise hand function on your Zoom, and we can recognize you for questions. While everyone is thinking, Jacob, I have a little question for you. What is your favorite topic in the frontier?
So for me, that would certainly be the noble elements. That's where most of my experience lies, and also kind of a thing where, in instrumentation, there's broad efforts to, make more precise detectors, lower energy thresholds, be able to detect lower energy events, more events. Just specifically, I come from the neutrino side. It's definitely my interests lie in the noble elements group.
Awesome. Does anyone else have any questions? All right. So we can go ahead and switch over to Marcel.
Hi. Okay, should I share my own screen here, or are we doing?
Go ahead and share your own screen.
Okay.
Professor Marcel Soares Santos received her PhD from the University of Sao Paulo in Brazil. She worked at Fermi National Accelerated Lab before becoming a Landsman Career Development Chair and Assistant Professor at Brandeis University, and she recently joined the faculty at the University of Michigan. She continues to study the nature of the accelerated expansion of the cosmos. Professor Soares Santos for the Cosmic Frontier.
Thank you. Thank you for the invitation, and also thank you for organizing this. It's great. I hope people can see my screen here. Does this make sense to everybody? I'll try to keep this short to allow time for questions. So I'm currently one of the 3 conveners for the Cosmic Frontier in Snowmass. And as it turns out, I also was in the previous version of Snowmass in 2013. I was an early career person back then, and participated in what we called at the time the Snowmass Young group. So if people have questions specifically about that experience and the challenges that we went through at the time and so on, I'll be happy to take those questions at the end. But here, what I'm going to do is just give a little bit of an overview of what is going on in the Cosmic Frontier and use this opportunity as well as a call for action for people here to get involved. I'm happy to see that there are quite a few people participating in this call today, and I hope that more people will join us as the process matures and evolves, right? So I think that once you got to the point of being here, seeing this presentation, you probably know what Snowmass is, but I like to put this slide up front because I think that there are some peculiar aspects of the Snowmass process that makes it amazing and makes it also a bit challenging, specifically for people who are in the early stages of their careers, and specifically also for people who are in the so-called cosmic frontier area. What do I mean by that? Well, first, the Snowmass is particle physics community planning exercise. So we have to think that the cosmic frontier is a relatively new component of the portfolio of the particle physics community, which means that for some of you who come from what I'm going to call the traditional high energy physics or particle physics world, there are a few things that are quite peculiar about the cosmic frontier. For example, the way some of our collaborations are organized, or the scale to which, for example, we need to combine data sets for multiple experiments to achieve our science goals. Some of those things are not so common, for example, for people who come from the collider physics world, for example, where you tend to think first of machines that last for 30 years and experiments that are thousands of people strong and all encompassing. So this is a little bit different in scale and diversity of types of experiments and of technologies that we use. So the Snowmass process happens every decade or so. Last one was in 2013, as I mentioned before. And oftentimes when we say this, people in the cosmic frontier who are also overlapping with the more traditional astronomy community, they tend to think about the astro decadal survey. If you're not an astronomer, you probably haven't heard about it. But and then people come with this question: oh, it's like the decadal survey, but for physics, right? And usually I say not quite. It is a exercise of planning towards the future, but the key difference, and that is an important part I think for all of us here, is that it is community driven as opposed to be commissioned by an entity up at the top like a funding agency. It is organized and created by the community. So the Snowmass process is led by the APS, the DPF, and with overlapping with other divisions as usual, as needed. But that's the reason why, for example, there is a big effort into supporting, for example, early career scientists participating in the process, because that is a strong part of the community and we want to have the input of the entire community in the process. Another thing that is peculiar about this Snowmass process is that it happens every 10 years-ish, but the context where we should be thinking about this is on a time scale of a bit longer, of 20 years. Why that? Because imagine the planning process lasts a year, a report will be produced at the end. This is also an important part. We need to think of like, what's the end product of Snowmass in a year from now? The end product will be a report that hopefully reflects a consensus in our community about what are our dreams and aspirations for our field in the context of the next decade or two. So we are thinking about experiments and things that should happen in a 10-year time scale. And more than that, something that can be will affect the field in a 20-year context. And this is challenging not only for early career scientists, but I remember when I did participate in Snowmass the first time, that was a very challenging thing to wrap my mind around, because we are typically thinking of, the next deadline of qualifying exam if you're a graduate student, or the next paper you're submitting, or at the most you're thinking about a project that you're going to do in the next 3 to 5 years as a as a new postdoc or something like that. It is not very often in our careers, in the beginning of our careers, that we have the opportunity to think and project our dream or our aspirations as scientists for such a long time frame. It is a difficult, it's an exercise that I found difficult at the time, and at the same time I found very rewarding because it did shape the way I thought and planned my career from that point to today. So that's an important component that we should say here. So this report later will be used by something called the P5 panel. That panel will take this scientific community-driven input and make a report that has prioritized list of which efforts we think should really happen and in what order, right? And this is important because funding agencies later will use this P5 report, not the Snowmass report directly, but the P5 report to make their funding decisions. So this will affect projects and things that we will be working on in the next 10 to 20 years, which means we probably should be taking the process very seriously. So if you're not convinced yet, or more yet, I would say that I like to provide this also as a resource for in case if you're having trouble convincing some of your colleagues to participate, especially when people think about timescale of 10 to 20 years, it's like, oh no, I really need to finish this paper now. I cannot invest time on this today. So I think that if you plan over the next decade or so, if you plan to remain active in the field and dream of working on exciting stuff, I have to say that was my motivation to come into this field, was to work on exciting new experiments, new ideas. So having the opportunity to dream about those is very good. If you have your own bold ideas, or if you're interested in building a strong network within the physics community, outside perhaps of your own institution, your own research group, and for you to listen and hear what are people talking about, what are the trends for the future of this field, even if you're not participating directly as a contributor to a particular paper or something like that. It's a great opportunity to see what directions are going, because you can incorporate that into your own plan for what type of research direction you want to take in your own career. So I think if you answer yes to any of these questions here, you probably want to get involved in Snowmass in one way or another. And we just heard from our previous speaker about a number of opportunities to get involved in leadership positions and so on. I would go here and say that even if you're just going in and listening to some sessions, and sometimes also on sessions that are on subfields that are a little bit far from what you're doing for your thesis or for your work right now, that can be enlightening and can be very beneficial. So I encourage people to do so. One thing that is important is that projects that are strongly featured in the Snowmass report, they have a greater chance than otherwise to become a reality. And one example of a successful thing in that area was the CMBS4 project, which became a part of the Cosmic Frontier in particular in the Snowmass 2013. That was not an area featured before, and now it is. So that is an important part of the process as well. Does not guarantee it will be funded, but it creates a greater probability. And so how are we organized? As you know, there are these different frontiers that have been created. The boundaries between them are, again, I wouldn't say arbitrary, but again, there are a million different ways that you could trace boundaries and divisions here. So overlaps are expected, and that's where all of the liaisons and so on come into play. The Cosmic Frontier in particular, where I'm most active, is organized in 7 topical groups, and that are listed here. I'm not going to read this for you. I think that one thing that is important is, for example, that we see topics that are, for example, the modern universe. So by modern, we are referring to here from about redshift 6 or 10 and below, after galaxies are fully formed and so on. That is a region where, for example, we can actually measure the accelerating expansion of the universe using those galaxies. And CF5 goes it looks more towards the early universe, but we know that our understanding of cosmology and dark energy will not necessarily, probably not come from either one or the other in particular, and that's why we really need to focus on complementarity, and we have a group that is working on that. Now, if you're not clear, there's a wiki page and whatnot, but if you're not clear, if like, oh, I don't know if my idea or if what I'm thinking is more in this area or that area, it doesn't matter. It is more important for you to, at this early stage, to join a group or to start participating, and then it will become more clear where things will go. And again, there are lots of overlap, so if you're not certain, it's probably because the topic you have in mind is in between there and overlapping between two places. So it doesn't really, I wouldn't worry about finding a single perfect spot for your favorite topic. I would say just participate, and these are some of the areas. I put here a list of who are the topical conveners, also my co-conveners, Aaron and Tim. There's detailed information, contact, emails, etc. in the Snowmass wiki page. People can access that and look for more information there. Just provide a list here. So if you are interested in getting engaged in the process and want to get in touch with any of the conveners and so on, I'm pretty sure people will be more than happy to help you get integrated into the effort and contribute in whatever way that we think is most appropriate. So now, hoping that you are interested and motivated to get involved, how do we do it? Start exploring the wiki page, join one of the topical groups. In particular, we haven't had yet a frontier-wide workshop, but we are organizing a workshop that will be involving this topical groups 4 to 7, and this will be a week from today. And here's the link with more information. I strongly encourage people to participate in that if they are interested in cosmology and cosmic frontier topics. Also, as somebody said earlier, email, Slack, etc., many ways to contribute and to participate. There are white papers that will be serving as the primary way that the community can give input to what goes into the Snowmass report. And these so-called letters of interest are due on August 31st for that purpose. The reason for that line being so early is that allows us to plan more efficiently for the workshop that will happen in October. So submit that. Remember, it's only 2 pages. So I like to think of that as like as if you were to write an APS abstract for a talk you're going to give in 6 months from now. Think of it that way so that you get the writer's block out of the way and can actually get it done. It is helpful to have, even if it's not perfect, it is more helpful to have it than not, because it helps us plan the early stages of the process and make sure that we don't let good ideas fall through the cracks just because we were not paying attention on those directions early on. Okay, and of course, I've been encouraging everybody to join the Snowmass Early Career Group and engage in the process. Okay, that's all I have. Thank you.
Thank you, Marcel. Does anybody have any questions? So one of the things that I was a little bit confused about when I was first looking into the cosmic frontier is what research areas are actually included in CF7. Could you list a few topics?
Yeah. So when we thought of CF7, the thought there was to be, I think maybe the title is not very as self-explanatory as we had hoped. We were thinking about cosmic probes of fundamental physics. So we were thinking of, for example, if you think of gamma rays or cosmic ray physics, we are thinking about cases where you were going to have access to fundamental physics or to measurements of properties of particles, etc., via cosmic probes, as opposed to, for example, building your own accelerator, making your own beam, right? So this would include a number of experiments that also do other types of science, also do dark matter, also do neutrinos, etc. One example of it would be Ice Cube, for example, or on Hawk, or experiments that are in that community, as well as gravitational waves, for example, where again there are lots of overlaps because we use gravitational waves as well in the dark energy as a dark energy probe. But in many cases, we are talking about probing fundamental physics with that, not necessarily, and that's the idea.
Awesome. Thanks for clarifying that. Does anyone else have any questions? All right, then maybe we can switch over to our final speakers.
Hello, let me share my slides.
So Amber Rope is a PhD student at the University of Oklahoma, and she is joined by Grace Cummings, also a PhD student, but from the University of Virginia, and they will be representing the energy frontier.
Yes, hello everybody. Grace couldn't make it today, unfortunately, so it will just be me. So me and Grace, as Tiffany said, we represent the Snowmass Early Career Energy Frontier Coordination. So I wanted to give you an idea of what the energy frontier is, what is currently happening with the energy frontier, and how the Snowmass Early Career Coordination is helping to get students involved, or early career members involved. So what is the current state of the energy frontier? So right now we have the Large Hadron Collider, which I'm sure every one of you know about. And for run 3, we're increasing the energy a bit to 14 TeV. We're also in preparation of getting the high luminosity LHC up and running. And with this, we'll have some unprecedented pilot conditions, and we're developing new technology for beam intensity at such high energies. And with this, we're slowly chipping away at Higgs and standard model measurements. We're also, with this increased energy, we're pushing the limits for new particle masses in the several TeV range. But what can we do more? If we ask for more and higher energy, this gives us direct production of more massive particles. Along with that, we generally get an increased production cross-section for rare processes. So what is past the LHC? So there are a number of future machines that are either starting to get funded or we're thinking about developing. And I wanted to go over some of those here because that's where most of the studies are happening within the energy frontier. So there's 2 main categories. There's hadron machines and then there's lepton machines. So hadron machines, we know them. We love them. Magnets are a challenge. So as I mentioned, we are upgrading the LHC to the high luminosity LHC, and so we'll have this new higher energy for proton-proton and heavy ion collisions in the near future. But what's past that? There's future hadron-hadron machines that we're currently developing studies for with much higher energy benchmarks. We're having some of the tentative benchmarks are 75, 100, and 150 TeV, which is fantastic. On the lepton machine side, it's been a while since we've had a high energy lepton collider. The last one that we had was LEP. So a lot of studies are going into looking at new lepton machines. Right now there's electron-positron machines in many different forms. There's the ILC, which is a linear collider, and there's also multiple circular colliders such as FCCEE and CLIC. The energy benchmarks for these machines range from tens to hundreds of GeV. But another consideration is also a muon collider. So muon colliders are much easier to make circular, but we have to worry about the muon lifetime. The tentative energy benchmarks for those machines are 3 and 10 plus TeV. A quick side note, the European strategy really prioritizes FCC hadron-hadron machines and lepton colliding Higgs factory. So we'll get into that a little bit further. But what does this mean for the energy frontier? So some of the things that we need to decide as we're looking forward for the next 10 to 20 years is, first and foremost, what physics do we want? Do we want to focus on di-Higgs protection, the top mass, SUSY? These are just some of the examples. And each topical group has to think about these and what the group as a whole really wants to see in the future. The second thing is what properties of the machines themselves do we need in order to get the physics that we want. So on top of what we want, we need to understand, the machine capabilities that we will need in order to reach those goals. And then, of course, in any measurement or analysis, there's other information that we will need. We need to consider theory calculations and whether or not we need to make those much better, or is there some way that Monte Carlo needs to change, or understanding ways to further reduce the uncertainties that we have. So these are some of the big questions that we have, and these are the big topics that these are the big goals that we're trying to achieve within the energy frontier. So I want to give you an overall view of the Snowmass energy frontier structure. As I mentioned, each topical group has their own specific physics goals in mind, and within each of those topical groups, there are numbers of letters of interest that are being made. So the energy frontier has 10 topical groups. They each have a slightly different focus, and they are spanning all of the physics that would be available with these high energy machines. There's also a lot of crossover. So today I'm just going to give a brief introduction into what each of these topical groups are focusing on right now. A quick caveat, the summaries I'm giving is a summary of the highlights of the topical groups that were presented at the Energy Frontier Workshop from July 20th to the 22nd. For more information, more detailed information on this, I have linked the third plenary session here, and then there is also more information on future colliders in a link back on slide 3. These slides are posted to the agenda, and feel free to take a look. So just some short overviews. The first kind of section is on electroweak Higgs physics. These are EF01 and O2. So EF01 is Higgs properties and couplings. What they're attempting to do is really understand the Higgs potential. They're looking at on precision measurements the Higgs self-coupling, and they're focusing on the machine capabilities of producing di-Higgs with very high statistics and low systematics, of course. And then they're also interested in other precision coupling measurements. EFO2 is interested in Higgs as a portal to new physics. So with these are a bit more rare, and with the high luminosity LHC, we have some additional accessible regions, and we want to understand which models have sensitivity, but we also want to explore new benchmarks new physics benchmarks in order to guide these future colliders. The next section is more specifically focused on electroweak interactions, and this is EFO3 and EFO4. So EFO3 is focused on heavy flavor and top quark physics, specifically the more, in terms of the high luminosity LHC, they're looking more into rare production modes and different clever ways in order to mitigate the uncertainties that comes along with it. And they're also have a big focus on probing the top mass. This is something that is very important to FITS, and this is valuable information at all colliders. So this is another big focus. For EFO4, this is precision physics and constraining new physics. So some of the new physics that they're looking at is the benefits of polarized beams with future lepton colliders, and how this affects certain things, including the LRA left-right asymmetry. They are also doing studies on precision W and Z boson physics, and also multi-boson final states. The next section is on QCD and strong interactions. This is EFO5 through EFO7. So there's a lot of really joint efforts on this on many different fronts, but every group has their specific topics. So EFO5 is on precision QCD. They're looking at getting the ultimate precision on the strong coupling. They're looking at some perturbative uncertainties in Monte Carlo production and understanding those much better. And then one of the recent workshops they held was on non-perturbative uncertainties. EFO6 is on studies hadronic structure and forward QCD. So they're focusing on the forward detectors in the high luminosity LHC era. This also includes high hadronic gluon density environments. And then, because this is certainly going to get more dense as we go to higher and higher luminosity. And then they're also interested in heavy flavor and excited bound states, and then and tetra and pentaquarks. So some really rare processes. And then EFO7 is focusing on heavy ions and how that's going to be changed, how heavy ion collisions are going to be changed for, sorry, I'm dog sitting. They're looking specifically at electroweak measurements. They're interested in studying heavy flavor quark gluon plasmas. And then they're also looking into axion, some other beyond standard model particles. But some of their joint efforts are on PDF determinations. Again, uncertainty mitigation is something that's very important, especially for these rare processes. And there's also a big focus on the theory needs for this particular group of topical groups. And then the last group is beyond standard model. These are EFO8, 9, and 10. We're kind of the cowboys and risk takers of the energy frontier. So these are very rare processes and all beyond standard model. So EFO8 is on model specific explorations. So some of the specific models they're looking into is composite Higgs, R parity violating SUSY, there's extra dimensions, there's leptoquarks, and there's the graviton, and there's so many more. EF09 is more interested in general explorations. So their focus is on how we, on model independent searches at these future colliders. Also, how we can probe long-lived particle signatures and what we need in detectors in order to do such, as current detectors are all designed for prompt signatures. And they're also looking into third-generation particle resonances and the sensitivity they have at these future colliders. And then we have EF10, which is specifically on dark matter. For this, as we can see, there is very heavy cross-frontier collaboration. There have been many joint workshops with this topical group and other frontiers already, and I expect there to be many more. They are focusing on two main categories. They're focusing on WIMPs and then beyond WIMPs, such as strongly coupled dark matter and dark photons and whatnot. So that's an overview of the topical groups and some of the projects they're working on within the energy frontier. So I want to get into the Snowmass early career involvement. So our goal as early career coordination is to help bring early career members into the Snowmass official processes. There are many reasons why there's a lower involvement, and we just want to encourage this and help people get matched with projects. And the Energy Frontier conveners are very excited to include more early career members. So we're just here to facilitate this. Some of the current projects that we're working on is study matching, which is great. We're working with the Energy Frontier conveners in order to develop a project database for not only expressions of interest, but for letters of interest and also for future white papers. So from the top down, we're creating this database of all of the available projects, but we're also going bottom up with creating a form and probing the projects that students are interested in and where they want to do work. So I'll talk about the interest survey again on the next slide, but there's also Monte Carlo workshops coming up. There's a specific Monte Carlo task force in order to determine and produce the Monte Carlo needs of the energy frontier. Since we have new colliders, we need to have specific Monte Carlo generated in order to perform these studies. So they're hosting some workshops to help Energy Frontier members and specifically early career members to facilitate this Monte Carlo production for these studies. There is the opportunity to help test the setup of these workshops before they go live to everybody. So you can contact the Energy Frontier conveners if you'd like to help out. I'll have their links to their information on the next slide. But then we also have bi-weekly chats in order to discuss developments in the energy frontier and also to hold discussions from the early career perspective as well. At every meeting, we have an update from each topical group liaison in order to inform our whole group of what's happening in each topical group, any major events that are coming up, workshops and whatnot. These meetings are every other Tuesday at 1900 hours Stern time or 12 o'clock Central time. We have a hard cap on this meeting at an hour because we understand we are all busy and so that's something we wanted to know. So we want to encourage everybody who's interested to get involved in some way. So our next Early Career Energy Frontier meeting is going to be August 11th at 7 p.m. Eastern Time, 12 Central, just as I mentioned previously. You can get involved in discussions on the different Slack channels they have. We have one specifically for the Early Career Energy Frontier Coordination. There are also Slack channels for general Energy Frontier meetings, a channel for discussions on different Energy Frontier topics, but also each topical group has their own Slack channel as well. We encourage you to fill out the linked interest survey for assistance, if you would like assistance matching with projects that are currently going on in the Energy Frontier. As I said, you can feel free to reach out to the Energy Frontier conveners and the topical group conveners. Those are all listed on the Snowmass Energy Frontier page linked here. We also have at least one topical group liaison from the Snowmass Early Career Energy Frontier group. These liaisons are here to facilitate the ideas of the early career community within those specific topical group meetings. So if you are attending a topical group meeting and there's something that you might not be comfortable bringing up, your liaison can bring that up for you. So feel free to take a look at them and contact them if you would like any more information. But there's also a couple of listservs that you can subscribe to in order to get information and announcements on meetings and whatnot. There's the Snowmass Energy Frontier listserv for all of the Energy Frontier meetings and announcements, but we also have a listserv specifically for the Early Career Energy Frontier meetings and announcements. That is all that I have. Does anybody have any questions?
Thanks so much, Amber. If anybody has any questions, feel free to raise your hand or write in the chat box. So just to be sure I'm clear on this, what is the best way of getting in touch with the SEC Energy Frontier liaisons?
You can, in order to contact them, we have the list of everybody for each topical group linked here. You can feel free to reach out to them via Slack. Their email should also be there. But if for some reason you're unable to find their information, you can absolutely contact me or Grace on Slack. We always have the app open. So yeah. So please feel free to reach out to any of us for more information.
Awesome, thanks so much. Does anybody else have any questions? Jacob posted something to the chat. He says, if you're interested in the Early Career Instrumentation Initiatives workshop, he's posted a link in the chat and it starts at 1:30 p.m. Eastern Daylight Time today. So with that, I want to thank everyone for coming. This meeting has been recorded and the recording will be posted on Indico as soon as we get it downloaded and uploaded.